Alright, hello everyone. I decided to do section 7.4, question number 59. And this is referring to the phases of the moon, where they talk about as the moon revolves around the earth, the side that faces the earth is just partially illuminated by the sun. The phases of the moon describe how much of the surface appears to be in sunlight. And there's an astronomical measure of this phase given by the fraction f of the lunar disk that is lit. And when the angle of the sun, the earth, and the moon is set to theta, it would be somewhere between 0 and 360 degrees. And they ask us to determine the angles theta that correspond to the following phases of f. For the first one, we got where f equals 0, which is a new moon. And that will end up being when the moon is actually positioned right here. All you have is the dark side of the moon facing the earth, obviously, because the back side is what's lit, but we can't see it. So when f equals 0, what we'll do is we just we'll actually work out the problem. And here's the equation up here that I'm working off of. It's right in the book though. Okay, so where we have the 1/2, we just multiply both sides by 2. And obviously this side's still 0. So we have 1 minus cosine theta. And for here, if we add cosine theta to the other side, we just get cosine theta equals 1. And where cosine theta equals 1, if we remember the unit circle, that's the value of x. So x equals 1 when theta is equal to 0 degrees or 360 degrees. So that's our first phase right there. Now our next phase is going to be when f is equal to 25. That's a crescent moon. And that will be when the moon is at an angle over here. Or it could also be down here. Alright, so we'll go ahead and work the problem out again real quick. And multiplying both sides by 2. Get 1 minus cosine theta. Add cosine theta to the other side, and I'm going to do this all in one step because this is all pretty basic math here at this point. We'll get cosine theta over here, subtract 1/2 from the other side, get cosine theta equals 1/2. And again, going back to the unit circle where x equals 1/2 will be, it's actually at the pi over 3 section, but remember it can also be either one of these angles here. So pi over 3 we know is equal to 60 degrees. So theta can equal 60 degrees, or if we subtract 60 from 360, we know it can equal 60 degrees or 300 degrees. And that is the angle of the Earth to the Sun, the angle of the Earth, the Moon, and the Sun in a crescent moon. Alright, let me see. Your third one here is going to be F equal to 0.5, and this is listed as the first or the last quarter moon, which is a little misleading because it's a quarter moon is technically a half moon, at least visually how we see it. And we'll go ahead and work this problem out real quick, where we have 0.5 equals 1/2 1 minus cosine theta. Double both sides, you get 1 equals 1 minus cosine theta. And add cosine theta to the other side, equals 0. And where cosine theta equals 0 is when the x value is equal to 0, which is, again going by the unit circle, which is when x would be 90 degrees or 270 degrees. Again, you can subtract that from 360 or so. That's the angle measurement of the quarter moon. And the last one they ask us to do is the full moon, where F is equal to 1. And the full moon would be when the moon's on this side of the Earth. I think I kind of drew a super moon there. Alright. And again, we'll work out this problem here. We got 1/2 1 minus cosine theta. Double both sides. Add cosine theta, subtract 2. You get cosine theta is equal to -1. And when we have cosine theta equal to -1, again looking at the unit circle, we know that that is when it's the value of just pi, and that is actually when theta does not have two separate degrees here. You're just going to have theta is equal to 180 degrees. And that's the value of the full moon right there. It's just 180 degrees. It doesn't have two separate angles. And I actually, just because that is dealing with something, it's a real life thing that we see every day, I actually looked up what the current phase of the moon is tonight, and I figured I would go ahead and add that and incorporate it with the equation. I looked it up, and tonight's moon is actually at 74% illumination. So F would actually equal 0.74. And if we were to work that out on here, you'd have 0.74 is equal to 1/2 1 minus cosine theta. Double both sides, you get 1.4 is equal to 1 minus cosine theta. Add cosine theta to the other side, subtract 1.4. You end up with cosine theta is equal to, what was it, give me a second, I lost my. Cosine theta, the angle, is equal to 113.58 degrees, or it could be 246.42 degrees. Now, what that would put it at is actually either right up here or right down here, where